Hello, and in this session, we are going to be doing conditional probability. But first, let's do some basic probability problem. A coin is flipped 3 times. What is the probability of getting 3 heads? The sample space is all possible outcomes when a coin is flipped 3 times. The cardinality of the sample space is 2 power 3, which is 8. E is the number of outcomes in which there are 3 heads, which is only 1 since we're flipping a coin 3 times. The probability of E is cardinality of E over cardinality of S, which is equal to 1 over 8. What is the probability of getting 3 heads given that the first flip came of heads? The formula for conditional probability is that the probability of E1 given E2 is equal to the probability of E1 and E2 divided by the probability of E2. E1 is getting 3 heads, while E2 is the first flip being a head. Probability of E1 intersection E2 is equal to 1 over 8, because since we're flipping a coin 3 times and we're getting 3 heads, all of the flips must be heads, including the first flip. P of E2 is equal to 2 squared over 8, which is equal to 1 over 2, because the first flip must be a head, but a second and third flip can be either a head or a tail. By this, the probability of E1 given E2 is equal to 1 over 8 divided by 1 over 2, which is equal to 1 over 4. What is the probability of getting 3 heads given that our first 2 flips resulted in 2 heads? Again, we use the conditional probability formula. Here, E1 is getting 3 heads, and E2 is that the first 2 flips gave us heads. P of E1 intersecting E2 is 1 over 8. Because we're flipping a coin 3 times and we're getting 3 heads, all of them must be heads, so the first 2 flips must be heads. The probability of E2 is 2 over 8, because since the first 2 flips must be heads, but a third flip can be either a head or a tail. Hence, P of E1 given E2 is equal to 1 over 8 divided by 2 over 8, which is equal to 1 over 2. What is the probability of getting 3 heads given that at least one of the first 2 flips resulted in heads? Here, E1 is getting 3 heads, and E2 is that at least one of the first 2 gives us heads. P of E1 intersecting E2 is equal to 1 over 8. By complementary counting, P of E2 is equal to 1 minus the probability that first 2 give us tails, which is 1 minus 2 over 8, which is equal to 6 over 8. Hence, probability of E1 given E2 is equal to 1 over 8 divided by 6 over 8, which is 1 over 6. What is the probability of getting 3 heads given that at most one of the first 2 flips resulted in heads? E1 is getting 3 heads, and E2 is that at most one flip gives us a head. Probability of E1 intersection E2 is 0, because since we're flipping a coin 3 times and we're getting 3 heads, all of them must be heads. However, if at most one flip gives us heads, that means at least one flip must be a tail. So all of them cannot be heads, so the probability of E1 intersecting E2 is 0. Hence, the probability of E1 given E2 is equal to 0.